triumUSA is proud to present its new innovative technology for the containment and redirection of oil from a deepwater oil well. Today, oil in all its forms is an essential part of the world's strategy for meeting its energy needs. Undersea exploration and acquisition of crude oil is a key component of that strategy. However, from its inception, undersea exploration and drilling have generated strong environmental and economic concerns surrounding the fear of a massive oil spill disaster. As evidenced by the 2010 Deepwater Horizon oil spill, the impact can be devastating. In the first 85 days alone, estimates were that between 93.5 million and 184.3 million gallons of crude oil were spilled, poisoning coastal marshes, destroying marine ecosystems, and devastating the economies of fishing villages, tourist destinations, and countless others who depend upon the Gulf waters for their livelihoods. Some experts believe that the environmental damage may be permanent, and that the short and long-term economic impact will reverberate throughout the global economy. The United States and indeed the world are in desperate and immediate need of a technology that will control and aid in the prevention of such disasters. To meet this need, triumUSA has developed an apparatus and method for containing oil from a deepwater oil well. Applied to a damaged well or constructed as a preventative safety measure when drilling a new well, the triumUSA technology works by containing the spilling oil in a multi-staged modular containment stack equipped with remote-controlled anti-blowout valves for equalizing interior and exterior pressure. The flowing crude is then directed from the containment stack through a connected flow tube to surface tankers for storage, thereby containing the oil and protecting the undersea ecosystem. The modular containment stack consists of a concrete anchor section, upon which are attached several riser sections, also constructed of concrete, which are in turn topped by a capping section made of stainless steel. The specifications and the number of risers required for the containment stack are determined by the depth of the well and the pressure to be equalized. Therefore, the containment stack may range in overall height from 5 to 50 meters, and its diameter may range from 1 to 10 meters, with the thickness of the anchor and riser stages ranging from 1/2 to 5 meters. Whether used as a preventative safety measure installed before or during the drilling process, or as a containment response to an ongoing spill, the triumUSA modular design and step-by-step process work together to minimize environmental and economic risks. First, an anchor position is determined for the placement of the containment stack. This position can range from 2 to 10 meters from the well itself. Next, the anchor section is introduced and secured to the ocean floor to secure the containment stack. A gasket section is mounted to the top of the anchor section. The first riser section, containing an inlet valve and an opposing outlet valve, is then mounted to the top of the first gasket. The inlet and outlet valves are then adjusted to equalize the pressures inside and outside the first riser section. A second gasket is then mounted to the top of the first riser section. The second riser section, also containing inlet and outlet valves, is then mounted on the second gasket. The inlet and outlet valves are adjusted to equalize the interior and exterior pressures at the second riser level. This is followed by the mounting of the third gasket section on the top of the second riser. The third, and for this example, final riser section, with inlet and outlet valves, is then mounted on top of the third gasket and secured in position. The inlet and outlet valves are adjusted to equalize the interior and exterior pressures, and the fourth gasket section is added. The containment stack is then topped by the upper section, consisting of a riser section and attachment to the flow tube. The upper section is mounted atop the fourth gasket section to complete the containment stack. Pressure inside and outside the apparatus is then equalized through a combination of suctioning out the crude oil at a predetermined vacuum pressure and readjustment of the various inlet and outlet valves. This completes the assembly portion of the triumUSA technology As you can see, it would now be ready to contain and salvage the crude oil flow while protecting the delicate undersea environment. It is simple, efficient, and practical. Whether applied as a disaster response tool to regain control of a damaged well, or used as a preventative safety measure installed before or during the drilling process, the triumUSA technology provides a cost-effective response to the dangers of deepwater oil exploration and drilling. The world is in desperate need of this groundbreaking technology, and triumUSA is working hard to introduce it into oil industry procedures as quickly as possible. But we need your help to bring this technology to the attention of oil industry leaders and our elected officials. Visit our website, triumUSA.com. There you'll find information and tools to help you contact your elected officials, easily voice your support, and help spread the word. Join us to strongly urge that our state and national representatives review this technology and make it part of all future deepwater oil drilling procedures. Working together, we can begin to ensure that devastation like that of the 2010 Deepwater Horizon oil spill never happens again.